This is Professor Russell Wilson. This person wanted a graph of the secant that happened to have a local minimums at 2/7 and also a period of 6 pi. First of all, notice the regular secant standard form, y equals a secant bx plus c. We don't have the c this time. C is the vertical shift, but we are going to use the b to try to find the period, and the a is the amplitude. The regular secant, a is just 1, 2 pi is the period. So for this secant here, let's have an amplitude of just 1. So let's have the amplitude be 2/7, which is going to give us a local minimums at 2/7. And by the way, it's also going to give us local maximums at negative 2/7 by the amplitude. But they want the period to be 6 pi. The ordinary period is tau is 2 pi over b. Well, this time, if we want the period to be 6 pi, notice how 6 pi, if it would equal 2 pi over b, the b would have to be 1/3, because 1/3, well, 2 pi divided by 1/3, when you flip the 1/3, you get 6 pi. So we're assuming that the b is 1/3. So now we have an equation that looks like y equals 2/7 secant x over 3. That accounts for the 1/3 x and the amplitude. So this is the final version of the equation. Now, how did I get the graph? A little xy table here. If the x equals 0, noticing that your secant x is 1/cosine x. So 1/cosine 0 will be 1/1, right? But in this case here, I happen to have a 2/7. Let's come down here, 2/7 secant x over 3. So if x is 0, I have the secant 0 is 1, and 2/7 times 1 is 2/7. So I did some clever drawing here. Instead of the usual negative 2 pi, negative pi, 0 pi, and 2 pi, I have negative 6 pi and 6 pi because that's the period. So I cut it down to 3 pi, 0, and 3 pi. So I have 0, 3 pi, 6 pi, negative 3 pi, negative 6 pi. And because of that, these are going to come out nice. The 3 pi, for instance, that's going to cancel the 3's, and secant pi is -1, and -1 times 2 pi is -2 pi. The 6 pi, it would cancel to 2 pi. Secant 2 pi, just like secant 0, because 2 pi and 0 are coterminal. So that would be 2/7 times 1 is 2/7. The secant of negative 3 pi over 3, that would cancel the 3's. Now I have a negative, right? But cosine is an even function, so it goes right back to the same positive that it was before. So that would be the secant, that would be secant pi, and 2/7 times -1 is -2/7. And finally, the negative 6 pi goes back to positive 6 pi because cosine is an even function. That would cancel down to a 2 pi, and 2/7 times secant 2 pi is 2/7. 1 times secant 2 pi is, 2/7 times secant 2 pi, 2/7 times 1, which is a positive 2/7. So therefore, we do have the minimums at 2/7. They didn't ask for it, but we have the maximums at negative 2/7, and we have the period at 6 pi, which is what the person asked for.